Yes. I can see a lot of reply, and still I'm waiting for others' reply. So in this case, when I ask questions, people are dropping off. So this is the normal distribution. What kind of inference you can make it by looking at it? See here, the income we apply. The income is plotted in the x-axis. In the y-axis, you can see the frequency. What kind of inference you can make it? What kind of story you can tell? It is a normal distribution. Very good, Prem Kumar. Right? It's a normal distribution. What kind of story you can tell? This chart tells us the story, right? What kind of story? See, this is a technical chart, guys. Remember this. This is technical chart. Histogram, interpreting the histogram is not the responsibility of the business user. Even the data analysts, they know what is a bar chart, column chart, pie chart, but they do not know what is histogram. They may be aware of histogram, but how to interpret by looking at the histogram, how to interpret that, they do not know. That is where the data scientists like you need to help the management or the stakeholders to understand the story behind this visual. Look at this. Here what kind of story can tell? What is the most common income range here? What is the most common income range here? 40,000 to 50,000. This is the tallest one, right? This rectangle is tallest one. The mode is here, right? 40,000 to 50,000. In this case, 364 people, 40,000 to 60,000. If you see, looking at this itself, you can tell, right? 40,000 to 50,000 salary drawn by 364 employees. And if you look at visually, you can tell the same thing. Okay, and what other story you can tell? So this is the most common income range. And then least common income range. What are the least common income ranges? The least common income ranges are like, 0 to, so we can say 0 to 10,000, but in the 0 to 10,000, we don't see anyone, right? None of them are getting, no individual is falling in that bracket. And then least common income range, and 80,000 to 90,000. And we can see that 90,000 to 1 lakh is there. 90,000 to 1 lakh and 80,000, I think nothing is there. 70,000 to 80,000. Okay. So low frequencies. Look here, the frequency is just maybe, right? How much? 23. 23 is somewhere falling here, right? So this is your frequency, guys. How many number of times? How many number of employees are falling in this bracket? 70 to 80,000. How many number of employees are there? 23. All of you, please type it in the chat window. All of you, please. So what are the common? Least common is, we can say 10,000 to 20,000 is least common. Yes, Prem Kumar, very good, right? And Leela, you are correct. And 70,000 to 80,000 and 10,000. See, with this 10,000, 20,000 salary drawn by how many number of people? Only one person. This is the least common. This is the least common income ranges. This is the least common income range. That is what we can see here. The 10,000 to 20,000 is the least common. And even this one also least common, 70,000 to 80,000. And the next one is, the distribution is, so other thing is, what other story you can tell? We can say the distribution of income is approximately symmetric distribution around the 40,000 to 60,000, 40,000 to 60,000, right? These two things, symmetric around 40,000 to 60,000. That means most of the individuals' salaries are between 40,000 to 60,000, but only few employees' salaries are 20,000 to 30,000, 10,000 to 20,000, 70,000 to 80,000. Okay, and can we see any skewness here? Can you see any skewness? What is skewness here? Yes, 20,000 to 30,000 and 70,000 to 80,000 also same, correct? Yeah, 70,000, 80,000 is 23 and 23, yes, correct. Only few of the employees are getting less salary, and only few of them are getting high salary. That is what we can see here. Only few of them are getting less salary and few of them are getting high salary. And most of the people are getting salary between 40,000 to 60,000. I need to compare the table here. This is not a rocket science, right? 50,000 to 60,000 if you see. How many? The frequency it shows 335. So 364, 335. These two numbers are big compared to other numbers. So with this, we can conclude by looking at this table itself, we can conclude people, 360 employee 364 plus 335, how much? 699 or so, right? Almost 700 employees are getting salary between 40,000 to 60,000, 40,000 to 60,000. Got it? That is what. So here we don't see any skewness, but there is a mild skewness here, 0 to 1,000, but we don't see anyone is getting salary in that man. And what is the purpose of histogram? Why should we have to use histogram? Can't I use bar chart? You can use bar chart also. With that also you can interpret. In the case of bar chart, what we do is we remove the space between the bars. Okay, then it will become your histogram. Okay, so why we need to use histogram? Using histogram, you can find out the distribution pattern for your variable. In this case, income is plotted in the x-axis. You want to see the distribution pattern of the income. In this case, it is normal distribution. So what we can control, the income is normally distributed. In this case, the income is normally distributed, but in the real world, income is often not normally distributed. Okay, and is typically right skewed, with few individuals earning significantly more than the rest, something like that. Okay, in the real world, it is different. In the real world, most of the cases, it will not be normally distributed, approximately normally distributed. Okay, just give me a second. So are you able to understand? And importantly, statistics students, I think, they should have covered during college time. I don't know. Okay. And anyhow, no problem. You can at least utilize this opportunity to understand this one very clearly. Okay. So next one is the, another example here, the distribution, customer sending amount. There is a column called customer spending amount. Can someone tell me, is this a normal distribution or skewed distribution? Can you make it a little bit faster? And give me the story around this quickly. When I explained it last week. What is the kind of distribution is this? Statistics guys, can you tell me quickly? At least statistics people should tell, right? I explained you now. Yeah, Prem Kumar is correct. Prem Kumar is not having statistics background, but I can see a quick response from Prem Kumar. How about others? Is this a normal distribution or not? Can you all please make it fast? Where is the mode is there? So where is the peak? We can see where is the peak? Where is the peak? Let me unmute. I think whether you people are opening or not. Can you all please unmute yourself? Jay Prashant 100. Very good. How about others? Only Jay Prashant. Yes. At Dhanraj 100. Very good. The peak is at 100. We already see. If you can answer it quickly, I can skip this topic and then I can go to the today's agenda. Okay. We can speed it up. So what the most customers, right? They spend most of the customers, they spend around $100. That is what the understanding here. So in this case, the distribution of customer spending is approximately symmetric. There will be some kind of skewness, okay, here, but it is approximately symmetric. In the real world, you will not get the bell curve, exact bell curve. It will be something like that. And then what other stories you can tell here? Most common customer spending amount is $100. What other story can tell that here? And few customers, they spend more than 120. Let's few customers, they spend Only few customers, they spend more than $140. We can say that way, right? Only few customers, they are spending more than $140 or 130. Only few customers, they are spending more than $130 or $130 and above. Okay, that is what we can see it here. Only few customers are spending more, but the average spend is just $100 only. And the majority of them, if you see, right, $80 to $120, they are spending it. $80 to $120 spent by majority of the customers, we can say. Only few of them are spending $130 and above dollar, and only few of them are spending and almost $60 and above. Okay, that is what the most common amount spent is, between $80 to $120. So why should I know this one here? So by knowing this, we can find out the potential customers, high value customers. Those customers spend more in our shop. They are our high valued customers. Okay, so they are very important to our business because they are spending more. When you give any special offer, for those kind of loyal customers, and those customers spend more. Okay, they are, so it's very much important. Okay, understanding the high spend customers, they are the high value customers. So we can come up with a special offer or something like that to retain them. If they leave our business, it is going to be an impact, right? So in this case, the tails of the histogram, it will show you the outlier in the data set. Okay, there are few customers who spend significantly more or less than the average value. Average is 100, less than the 100, less than the average spend 100 or above 100. Only few of them are spending it. That is what the story we can tell it to our management. And apart from histogram, using histogram, we can find out the distribution pattern of the data set. And apart from the histogram, we can also use box plot to view the distribution pattern. So what other purpose the box plot is helpful? Can someone tell me quickly? Not someone, all of you, please type it in the chat window quickly. For what purpose box plot is helpful? To visualize the distribution pattern, whether the data is normally distributed or not. Like in the histogram, we see whether the data is distributed normally or not, right? Similarly, we can use box plot. Apart from understanding the distribution pattern, for what other purpose we can use the box plot? All of you, please make it fast. Make it fast. Make it fast. None of you are aware of it. What is five number summary? So that means, right, you guys need time to prepare, or if you don't get time to tell me, sir, we will have the session tomorrow, I can compensate today's session on Monday also. Yeah, to find the similarity of the data. Dhanraj, okay. And Prem Kumar Natarajan, he says IQR, okay. What other purpose we can use box plot? What other purpose? Box plot. All of you have forgotten it. Working people, fine. How about others? Okay, distribution, variability, and central tendency. 5 number summary. I told you 5 number summary. If somebody asks, box plot, the first thing that should come to your mind is 5 number summary. What is 5 number summary? Can you all please type it in the chat window quickly? Minimum, maximum, median, lower quartile, lower quartile. No. Partially you are correct. Minimum, maximum, median, lower quartile, upper quartile. See, this is your lower quartile. This is your lower quartile. This is your upper quartile. This is what your median. This is what your minimum, and this is what your maximum. Right? In this case, 50 is the maximum, 10 is the minimum. The median is 30. The lower quartile is 15 almost, and here 45. What happened, guys? Upper quartile, correct. This is what, using the histogram as well as the box plot, we can find out the distribution pattern. And at the same time, if the distribution pattern is normally distributed, it is pretty simple. The mean and median, mean median mode will fall in the middle. With the box plot, we can find out the 5 number summary quickly, minimum value and maximum value. You might be saying that the minimum value is here, maximum value is here. You can say here also. And with both with box plot as well as the histogram, we can find out the outliers. If you find anything above this line, for example, the maximum, right? Sorry, this exact thing. Okay, this is the line. Anything above this, if you see, that is your outlier. If you see any dot here or something like that, that means there are some outliers are there in your data set. Using box plot as well as histogram, you can find out the outliers in your data set. Next one is skewed distribution. We discussed what is skewed distribution. What is, first of all, skewness is all about. Skewness is a measure of symmetry. Okay, it will help us to, the skewness will help us to measure the level of symmetry in our distribution. Okay, so but that means, right, it tells us whether our data deviates from the deviates from the norm or something like that. Sometimes what will happen is the normal distributions tend to tilt more on one side or more on the left side. This is because the problem with the data being more or less than the mean is mean, right? More or less than the mean. And also it tells us the data is not normally distributed. Okay, no, you're not equally distributed or normally distributed. We can tell that way. Yeah, Jiva, no problem. I'm not, asking you. Others, those people. Okay, skewed distribution exhibit a longer tail on one side, either on the left side or right side. And positive skewness indicates a longer tail on the right side. Negative skewness implies a longer tail on the left side. So can someone tell me what kind of distribution is this? This is very important, fundamental thing. You should be knowing it. The interview, they'll ask you these kind of basic questions. If you cannot answer, they'll say, we'll get back to you. They'll disconnect the call. Now you tell me what kind of distribution is this? Yes, very good, very good, very good, very good, very good. Okay, very good, right? But how about statistics students? Statistics are not at all opening their mouth. Jai Shri, and Jai Prashant, Danraj, Jivananda. Okay, fine. I understood. He's outside. Yes, Raji, you are correct. Leela, you are correct. Sara and Soumya, you are correct. See, this is negatively squeezed. This is not normally distributed, right? This is not normally distributed. See, the normal distribution is something like this. It will be something like this, right? It will be something like this. But here it goes here. If you connect, and then it goes something like this. The tail is longer here. But whereas if you see here in this case, the tail is not so longer. The previous one is the normal distribution. So this is the one is your normal distribution. If you connect all the end, for example, if I draw a line by connecting all the edges, this is your normal distribution, right? When you connect it, you can see both sides, the tail is somewhat, similar. But whereas here it is not normally distributed, it is the tail, we can see a longer tail on the right side of the peak. This is what your peak. On the right side of the peak, this is your positive skewness or right skewed data. So now the customer spending amount, we take the same example. What kind of story we can tell here? The peak of the histogram is around, let's say not the $20 here, right? And there is a long tail to the right of the peak. Okay, so this means that there are a few customers who spend a lot of money. Only few customers, they spend a lot of money. But most customers spend less than $25. only if sorry, in this case, yeah, most of the customers, they spend less than $25. Only few customers, they spend $30 and above. That is what we can see that here. The long tail to the right tells us that there are few customers who spend a lot of money, few customers. These customers may be high value customers who make large purchases, or they may be outliers who spend a lot of money on a single item, something like that. So this is the average amount of money here. Okay, that's what we can say. That's the story we can tell here. And next one is this is the right skewed data. That is what we have seen it here. So this is the right. In this case, okay, I will come back to that little later. And what kind of distribution is this? This is a left skewed distribution, because this is what my peak here. This is what my peak here. On the left side of the peak, we can see a longer tail here. If you connect a line here, what will happen? Your tail is too long, right? If I connect a line here, the tail is too long here. This is what your peak. Anything on the left side of the peak is called your left skewed or negatively skewed distribution. So this is what we can see here. Here I have given this example: website visitors and frequency. So between 0 to 100 customers, they visit 10 times. Okay, and 100 to 200 customers, they visit 20 times frequently. Okay, and that is what we can see there. 100, yeah, that is what we can see here. The website visitors. So what other story you can tell here? What other stories you can tell here? 1,000 to 10,000. What does it tells us? 1,000 to 10,000, 200 customers. So most of the customers, with 1,000 to 10,000 customers, they visit 200 times here. Okay. What other story you can tell here? Do we have any outlier here? The 0 to 100, the 0 to 100 can be potentially considered as outlier, isn't it? Compared to other value, this is less, isn't it? This is an outlier, right? Compared to other value, this is very less. Hence, it is an outlier. Okay, we can make out, without using the formula itself, we can make out. Since there are only 10 instances in this range, it is quite different from others, right? Hence, it is an outlier. So with this, you can quickly identify it here. 0 to 100 is an outlier here. We can see some kind of outlier here. And what other things you can find in the case of left skewed distribution, the mean is typically less than median. Remember, this is the property of left skewed distribution. Mean is less than your median. Less than your median. And your median is less than your mode. If somebody asks you, where is the mode? You can tell whichever rectangle that is taller, you can tell, hey, this is what my mode. Now you are clear. Mode is the tallest one. Irrespective of the distribution, you can tell where the mode is there in the mode is the tallest rectangle. Okay. And how about the median? Right? In the case of left skewed or negatively skewed distribution, the mean is pulled down by the lower visitors here. Okay, your mean will be there somewhere here. Between the mode and mean, your median will be there here. Median will be there. Hence, mean is less than median. So mean is less than median. Median is obviously less than your mode. This is the property you should be knowing. In the case of right skewed distribution, very good, very good. Prem Kumar, excellent, right? Prem Kumar said 10,000 to 1,000 to 10,000. We can see more number of visitors. Yes, this is also kind of an outlier. Yes, you are correct, right? This is also an outlier. This is also an outlier. Excellent. Okay, but remember that this is the property. Okay, mean is less than median. Median is less than mode. in the case of left or negatively skewed distribution. Okay, how do we find out in the case of left skewed or right skewed? How do you find out the mean? How do you find out the estimated mean here? So you need to find out the midpoint for each and every interval. So 0 to 100. So here 100 plus 200 divided by 2. So 100 divided by 2 is 50. Okay, likewise, you need to find out the midpoint for each and every interval. Multiply that midpoint by the frequency. So here 10, right? So here, what is the midpoint here? 50. 50 into 10 is 500. 100 plus 200 is 300. 150 into 20, which is your 3000. And then you need to add all the values. So midpoint value you need to find out for each and every interval. And then each midpoint, each interval midpoint, you need to multiply by the frequency and you need to add all the values. If you add all the values, you will get the total weighted sum. And then you need to add the total frequency. The total frequency is 450. Then total weighted sum divided by total frequency, that is the one will give you the estimated mean. So you can tell them the estimated mean number of visitors is approximately 2,700 or so. Okay, if somebody asks you, what is the estimated average number of visitors? You cannot tell, right? So you need to use this formula and then you can tell it. Okay, next one is how to compute the skewness. Is there any formula that is available to compute this skewness? We know what is skewness. Skewness is a measure of asymmetry of a distribution. Just by visualizing the histogram, we can tell whether the given data is, the distribution pattern for the given data is normally distributed or left skewed or right skewed. We can find out. So are there any formula? Yes, this is a formula is available to measure the skewness. Pearson coefficient of skewness and moment coefficient of skewness. This is also available. This is the one is commonly used. Okay, in this case, 3 into mean minus median divided by standard deviation. If you use this formula, you can get the value for your skewness. For example, let's say we have the data points something like 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 values are there. What is the mean of this data set? What is the mean here? You need to add all the values divided by 9. You will get 5. Am I correct? The mean is 5 here. Okay, and the median is also 5. Because in the middle value, 1 second, here 4. Yeah, this is the median. Median is 5. We have the value for mean and we have the value for median. Standard deviation we need to compute it. In this case, the standard deviation is 2. 2 here. So if you plug in these values, 3 into 5, 5 is my mean. Median is also my 5. Okay, and divided by the standard deviation is 2 here. In this case, what value are we going to get? 5 minus 5 is 0. 0 into 3 is 0. 0 divided by anything is 0. So if the skewness is 0, what does it tells us? If the skewness formula, well, let's say you've plugged in the values in the ES Prem Kumar. Okay. So here, if you plug in the value here, okay, since we this is the data set, we plugged in the value here. To plug in the value, first you need to compute the mean, find out the median, subtract the median from your mean, multiply this value divided by standard deviation. Standard deviation is 2 here. In this case, your numerator is 0. Anything 0 divided by anything is 0, right? So if the skewness is 0, remember this. If the skewness is 0, it's a normal distribution. If the skewness is 0, then it is a normally distributed, normal distribution. Normal distribution or Gaussian distribution or something like that, okay? Let's say I'm going to add one more value here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to include one more value here, 10 here. In this case, what is the mean here? What is the mean? What is the median here? What is the mean, median, standard deviation? Mean is, can we say that, yeah, the mean is somewhat 6, right? And the median is 5 still. And the standard deviation is 3. And if you plug in these values, 3 into 1 is 3. 3 divided by 3 is 1. So in this case, the skewness is 1 equal to 1. So if the skewness value is more than 0, right? That means it is a positive skew, right skew. If the skewness value is 0, it is normal distribution. If the skewness is greater than 0, that means the right skew. If it is less than 0, that means left side, left skew. That's all. Yes, Prem Kumar, you are correct. Prem, yes, you are correct. Will the formula apply for any type of skewness? Yeah, yes, that's what I explained. If the skewness value is 0, it's a normal. If the skewness is greater than 0, that means the right skewed data. In this case, we are getting 1. The skewness is 1, hence it is greater than 0, hence it is right skewed. If it is less than 0, then it is left skewed distribution. Using the formula also, we can find out whether the given distribution is normally distributed or not, or left skewed or right skewed, we can find out. And one more important point which you need to remember is, look here, here, this is your negative skew. Why? This is where your peak is there. On the left side of the peak, we can see a longer tail ends. It is called your left skewed data. This is what your mode here, the peak, right? That is the peak is your mode. On the right side of the mode, we can see a longer tail. Hence, it is called positive skew or right skew. Positive skew or negative skew or right skew or left skew. They use different term here. But end of the day, the peak is your mode. Okay. And your mean will get dragged somewhere on the left side. In the case of left skewed, in the case of right skewed, the mean will get dragged on the right side. Between the mean and mode, your median will be there. You need to remember this very well. Now, I'm going to ask you some questions. I just go here and then I'll ask you this question. Let me see. Okay, can someone, all of you, please give me an answer for this one. First of all, what kind of distribution is this? Right skewed data. Okay. What is the correct answer here? In the case of right or left skewed data, the mean will get, will get dragged toward the outside, right? It will get dragged outward. What is the answer here? Let me see how many of you are concentrating, how many of you are not concentrating. If you don't answer it, you're not concentrating. Remember this diagram. Look here, remember this diagram, the image. So where is the mean is there? Where is the mean is there? Now you can you all keep this in mind, okay? Can you take a snap in your brain? Take a photo in your brain, okay? Your eyes are seeing it, take a photo, and then let's go back here. And then you tell me what is the answer here. This is a right skewed data. Right skewed data where the mode will be there. All of you, please type it in the chat window. Guys, I cannot help you if you cannot. Yeah, I can see that. Very good response. Good. So where is the mode here? The tallest one is your mode. Right? Where the mean is there, where the median is there. I showed you the picture, right? Where is the mode? First, you tell me where is the mode. Where is the mode? The mode is here. I'll give you that clue also. The mode is here. The mean get dragged towards the right side. The mean is somewhere here, right? The mean is somewhere here. In between the mode and mean, your median is there, right? That is what I said. Now, at least tell me what is the answer. All of you, please type it in the chat window. Very good, very good. Jay Prashant, excellent. And how about others? See, look at this multiple, it's a multiple choice question, right? There are multiple answers. You tell me, but look at this picture and you tell me. I wrote it everything here. Jayashree, are you there, Jayashree? And what happened to Jamal? Dhanraj? Jivanandam, okay, fine. How about others? Anwar, yeah, Soumya, you're correct. Sudha, you're correct. Sara, you're correct. Sangeeta, you're correct. Sai Sudha, you're correct. Raji, you're correct. Leela, you're correct. How about others? How about others? Almost 50. Tell me the answer, yaar. Tell me. See, what is the which? So which one is less than which one? Mode is bigger, right? And mean is lesser. I gave you this one also here. Tell me what is the answer now. Type it in the chat window. Dhanraj, are you there? It is not a contribution. See, only when I mean is less than median. So in the case of left skewed, tell me now which one is the correct answer. For example, in the same thing, I'll just draw it here. I'm going to have, let's say I have something like this. In this case, we have something like this. Now you tell me where the mode is there. The mode is there here, right? And what is the answer for left distribution for the same given question? Which one holds true for the left distribution? Forget about this one now. You look at this one now. The mean will get dragged towards the left side and the median will be there in between mode and mean, right? So now you tell me what is the answer. Correct. But many answers are coming, very good. But still statistics students, right? You need to respond quickly. Yes, you are correct. No. Still, okay, your answer is, the option 3. Okay, in this case, the mean is less than median, obviously, and median is less than mode, right? Still, the same thing. Mean is less than median. Median is less than mode, right? See, simple common sense here. Look here. Since the mean is there here, let's assume that some 10 is there. But obviously, since this is here, it will be obviously 20 here, maybe 50. So 10 is less than 20 is less than 50. This is your mean and this is your median. This is your mode. So mean is less than median is less than mode, right? Correct. Okay, next one is okay, to summarize, before we move ahead with the quizzes, we have some more quizzes. Before we proceed with the quizzes, let me summarize quickly. What is skewness? Skewness is a measure of asymmetry. That is what we discussed. And also we discussed about the properties of skewness. If the skewness is less than 0, the data are left skewed. And if the skewness is greater than 0, it is right skewed. If the skewness is equal to 0, the data are perfectly symmetrical, normal distribution. That is what we discussed. And also we discussed about the formula. With the formula, I have demonstrated with some sample data. With that, I have shown you how to plug in how to compute the mean, median, and standard deviation, how to plug in those values in order to get your skewness value. The skewness, and also we discussed the left skewed data, right skewed data, everything. And also we discussed about how to interpret the data also. Sorry, the chart, right? How to interpret the left skewed and right skewed also. Now you tell me next